Today, I want to discuss one challenge that affects all of us. Whether you're focused on defense or the commercial side of aviation, this is something that affects us all. It's the urgent need to restore our manufacturing and supply chain resilience in a world where geopolitical tensions and technological dynamics are rapidly shifting. In 2022, the world was shocked by a land war breaking out in Russia and Ukraine. And then in 2023, a conflict erupted in the Middle East. This was after everybody thought that the state of warfare was completely evolved. Going into cyber or going into economic warfare, here we are. Low-cost drones have emerged in the battlefield, exposing vulnerabilities in defense systems once thought to be secure. At the same time, we know that traditional capabilities are still very much relevant. And through all of this, people are wondering which questions they should even be asking. Is this a technology problem? Is this a labor problem? Or is this a problem of capabilities and scale? When we started First Resonance 5 years ago, this was a question that we hardly ever heard. Can we manufacture fast enough to defend ourselves in this new world? At the center of all these questions lie adversaries like China, and powerful companies like DJI working hand in hand with these adversaries. Together, they compete aggressively, if not directly in warfare, then at least economic warfare and the control of the supply chain. In fact, DJI controls about 70% of the global consumer drone market. And remember what I mentioned earlier, whether you are in the commercial side or the defense side, what happens in one affects the other. Why? Well, it's because where we get parts for the defense side or the commercial side, wherever it comes from, it affects the entire supply chain. China is being strategic about this by creating mandates about which products it produces and what supply chain sources those parts. For example, they have a mandate that critical parts need to be manufactured domestically, and in all likelihood, this is to bolster their own supply chain, but moreover, weaken others. So it's no surprise that China is sometimes referred to as the world's factory. Imagine knowing the factory producing the tools for your defense sits in the adversary's territory, and they can scale it up better than us. I'm not just here to tell you about this problem. I think we've been hearing about it in the news now. I'm here to tell you that there's some good news. The world is responding. From a policy and economics perspective, the last few administrations have introduced policies like the IRA, the CHIPS Act, the Made in America initiatives, and this has really become a nonpartisan issue. The Department of Defense, specifically the DIU, has launched initiatives like the Replicator 2 initiative, which emphasizes the need for low-cost, rapid deployment of autonomous systems. It also emphasizes the need to engage with the commercial dual-use sector to benefit from the rate of progress that commercial sector can provide. While initiatives like these are powerful, we believe that we are just at the forefront of a wave that is far from realized. That leads me to the elephant in the room. The problem we have is not just technology, it's about culture. Culture drives how we adopt technology and scale it. Without the right culture, technology, even the best technology, will not be adopted and it will fail in the battlefield. For decades, we've outsourced our industrial base. And in doing so, we've lost 2 generations of expertise and advancement in industrial culture. Meanwhile, China has cultivated a culture designed for rapid scale-up. They've built a supplier base, a manufacturing ecosystem, and a mindset that prioritizes speed and delivery of components to the whole world. So we have to do something about it. But we can't just copy our past playbooks or somebody else's playbooks. We have to build one that works for us in 2024. So how do we rapidly scale up manufacturing and supply chains to be able to support more innovative capabilities all in parallel? It's not easy at all. But I've seen this movie play before. About 12 years ago, I joined SpaceX when we were just a startup that most people did not know about. A lot has changed since then. I gained an in-depth understanding of the complexities of scaling, manufacturing, balancing supply chain, and tackling the kinds of problems that we're seeing in many industries today. How do we rapidly, flexibly, and efficiently scale up complex hardware programs? At SpaceX, we didn't just build rockets, we redefined how rockets were made. We explored manufacturing scalability, supply chain management, and application of advanced technologies like composites and additive manufacturing. We employed data science and predictive models, now more commonly referred to as machine learning and AI. And we developed new types of interfaces to empower human and machine collaboration. While everyone was focused on the digital experience online, we were focused on the factory experience. This allowed us to test faster, collect massive amounts of data, and use that data to refine our decisions and designs. It's this combination of speed, data, and innovation that helps SpaceX achieve flight reusability and scale up its operations. Today, we're bringing those learnings through First Resonance and applying them to over 50 companies, creating the new industrial base in the United States. Let's talk about two focus areas for culture that we need to evolve: manufacturing agility and supply chain resilience. Let's start with manufacturing agility. Think back to the history of scaling up manufacturing. In the 1940s, Terminal Island in Los Angeles constructed 467 Liberty and Victory ships over just 5 years, employing a workforce of 40,000 men and women. In the 1960s, Lockheed Martin Skunk Works designed and produced the SR-71 Blackbird, a high-altitude Mach 3 reconnaissance aircraft, in just 20 months. But we can't scale with the same approach today for a lot of reasons. However, we can lean on a particular strength we have, which is software. America leads the world in internet-scale technologies, and principles that drive our dominance in software can be applied to manufacturing. We can build factories where every sensor is connected and feeds into a series of interconnected systems, allowing real-time adjustments and optimizations. We can have speed and quality, and we don't have to choose between the two. Applying these technologies and using the assistance of powerful compute can allow factories to operate like modern data centers, where engineers are constantly measuring, optimizing, and scaling operations, and where modern collaboration UX can allow us to automate the onerous and manual processes that we have codified into our manufacturing culture without having to fully bust them. Developing factories like this allows for the kind of agility required by programs like Replicator. And they need to be complemented by the next focus area, which is supply chain resilience. Over the last few decades, globalization met principles of lean manufacturing, and efficiency became a mantra. But it's become clear that overextending on these principles comes at a huge cost. Our supply chains are optimized for cost savings, but are vulnerable to the disruption and incapable of scaling quickly. In a word, they're very brittle. And when things go wrong, they go very wrong. During the COVID-19 pandemic, we saw the automotive industry face significant challenges. US car sales dropped by 47% due to supply chain disruptions. And in aviation, we saw the compounded effect of design errors meeting supply chain fragility, piling up airplanes outside of factories, leading to huge losses for the aircraft manufacturer. This opened many questions, and these stories have now compounded to show us that our supply chains are quite fragile indeed. For those who are not in the day-to-day of building complex machines at scale, you'd be surprised just how much work goes into quoting, negotiating, receiving, managing, outsourcing, and qualifying suppliers to source parts critical to these complex machines. China and others have managed these through brute force and large labor forces. We can do better with the power of big data and advanced AI to make use of all that data to automate much of that manual work, while still maintaining integrity in the process. This helps supply chain managers deeply understand their supply chain, maintain its quality, and promote transparency between suppliers and vendors. This is where modern manufacturing platforms like Ion by First Resonance come in. Ion is a manufacturing platform by First Resonance that allows engineers to design, iterate, and produce faster than ever before. It allows for quick iteration, giving engineers the ability to solve issues in complex manufacturing, supply chain, and quality management. Designed by manufacturing and software engineers, Ion automates process-heavy supply chain management with modern compute and analysis capabilities to flexibly scale, while having the traceability required for rapid debugging and quality certification. It accelerates automating data capture, streamlining regulatory compliance, and providing end-to-end traceability with serialization. Today, manufacturers are using ION to provide the data they need for FAA certification and certifications like NQA1 in the nuclear industry, and many other quality and regulatory compliance standards. Using ION, one counter-drone defense company was able to quickly triage an issue in the field with their DoD customer and get their hardware back online. Another company is leading the charge in eVTOL certification using the data coming off of ION's as-built bill of materials to produce the data they need for their build records. These stories are on top of the common benefits that manufacturing platforms like ION can deliver, like 30% improvement in production times and saving millions of dollars of inventory cost loss. In just 5 years, we have more than 50 stories like these, powering factories taking on and scaling the largest challenges in energy, aerospace, robotics, and more. So yes, we can make drones, and we can make them faster than China, better than China, and all of the hardware that we need better and faster. It will take more than just technology. It will take a cultural shift and a commitment to innovation. It will also take a willingness to rethink what got us here won't get us there. Specifically, I believe that the 20th century was about production might, and the first part of the 21st century was about digital innovation online. The rest of the century will be about the convergence of the digital and physical worlds coming together to make a better world for us. With the work that we are doing at First Resonance, along with a rising number of companies bringing the physical and digital worlds together, we have the tools to innovate, scale, and compete at a level to transcend our adversaries' industrial might. We can secure our supply chains, we can build at speed, and we can promote a safer, more sustainable world for human progress. If we embrace the right principles and partnerships across technology, operations, capital, and regulatory, I believe the question won't be whether we can catch up, but just how much of a better world we can make for ourselves. Thank you.